In this video, we need to solve the following inequality, graph the solution set on a number line, and write the solution in interval notation. And here is our inequality. What's the degree? What's the highest exponent on any of our variables? A 1, so it's a linear inequality. And how do we solve linear inequalities? Well, we solve linear inequalities in one variable just like a linear equation in one variable, except there are a couple of exceptions. The first is when you multiply or divide the inequality by a negative number. This reverses the inequality symbol. And the second is if you interchange the two sides of the inequality, that also reverses the inequality symbol. So let's go back to our example here, and we're going to solve this linear inequality just like a linear equation with keeping those two exceptions in mind. So for a linear equation, how do you solve them? You get all your variables on one side, all your constants on the other. So I want to collect my y's on the left-hand side. So I'm going to subtract 5y from both sides. And remember, adding and subtracting things to an inequality does not change the inequality symbol. So I get 2y minus 5y is negative 3y minus 4 is less than or equal to 5y minus 5y is 0, so the only thing left on the right-hand side is negative 16. Now I need to add 4 to both sides. And remember, again, adding and subtracting things do not change the inequality symbol. So I'm going to get negative 3y, and remember, negative 4 plus 4 adds up to 0, is less than or equal to negative 16 plus 4 is negative 12. So that's just like solving a linear equation. But now to get y by itself, I'm going to have to divide both sides by a negative number. And what happens when you divide an inequality by a negative number? It reverses the inequality, so my less than or equal to becomes greater than or equal to, as I'm dividing both sides by negative 3. These reduce, and on the left-hand side, I get y is greater than or equal to negative divided by negative is a positive, 12 divided by 3 is 4. So I'm going to get y is greater than or equal to 4. So I've solved the inequality. Now I need to graph it. So here's 4. Greater than 4 means shade everything to the right. And then you put an arrow pointing to positive infinity. And on the 4, since it's greater than or equals to, we include the endpoint, so it's square bracket on the 4. So there's my graph, and my interval notation will look like square bracket 4, comma, infinity. Since you can't close in infinity, it always has to have a parentheses on it. So now I've solved my problem. But what I want to point out now is some students really don't like dividing both sides of an inequality by a negative number because they have to remember to reverse the inequality symbol. So what they think is, oh, it'd be a lot easier if I collected my y's on the right. So let's just do that very quickly. So I've rewritten my problem. So if I want to collect, that's a terrible 16, sorry about that. If I want to collect my y's on the right, I'm going to subtract 2y from both sides. Remember, adding and subtracting doesn't change the inequality symbol. 2y minus 2y is 0. So I get negative 4 is less than or equal to 5y minus 2y is 3y minus 16. Now to get the 3y by itself, you add 16 to both sides. Again, it won't change the inequality symbol. And I get negative 4 plus 16 is positive 12 is less than or equal to 3y. Last step, I have to divide both sides by a positive number. That will not change the inequality symbol. So I get 12 divided by 3 is 4, is less than or equal to, the 3 is reduced, and I just get left with y on the right-hand side. So they have solved the inequality. However, when they come to graph it, they put their 4 on the number line and they go 4 is less than or equal to y, and they're so tempted to shade here on the left-hand side of the 4. But remember, if we read this, you always read it from the variable, and this says y is greater than or equal to 4. And the best way to make sure you don't mess up on that is you reverse the inequality. It's like you put a mirror down here and you reflect it across, and you get y is greater than or equal to 4. When you reverse the order of an inequality, you reverse the inequality symbol. And now you see y is greater than or equal to 4. It's obvious that you're going to shade to the right and put a square bracket on it, and you will get the same interval notation. So if you solve the problem like we did on the left, you have to remember when you divide both sides of an inequality by a negative, it reverses the inequality symbol. But if you collect your variables on the right-hand side, don't be tempted by this to shade the wrong region and get the wrong interval notation. So both methods have their issues, so I suggest you pick the method you like the most and then stick with it.